The next one from 10th standard electricity, one important topic. Say for example, let us take domestic electric circuit. Um, Domestic electric circuit means in your home appliance. Okay. Um, Say for example, fan, then tube light, then heater. Then generally, if you pass the wire, if you pass the current through the wire in long time, say for example, let's take um, an electric bulb. Okay, so if you pass the current 1/2 hour, then after some time, then first switch off the bulb, just you touch the electric lamp, so we feel some heat, correct? Yes, even the not only that bulb, that wire also heated. So here some energy is dissipated in the form of heat. So now we are going to analyze that heat only, how the heat is generated, then what are the causes included. Say for example, now let's say take one circuit. This first I take one battery. This battery will be connected with one resistance. It's a resistance. Okay. Now we have to apply the potential, that is plus minus, it is some V voltage. The same voltage drop we can get across this resistor, that is V. Okay, this the resistance is R. Okay, now I want to measure this voltage, so I can connecting with one voltmeter. So this is voltage across the resistor. Now the current is passing through the circuit is I. Okay, right. Then now let's take one watch. Okay, we can measure the timing. Okay, so now starting time is for example 9 o'clock. Up to 9:30 I can pass this current through the circuit. So after 9:30 I switch off the circuit, just I touch the resistance, so I feel heat, because here some heat energy, some energy is dissipated in the form of heat. Okay, but some devices, they are utilizing this heat, so that the heat only is treated as some application. Say for example, heater, electric heater. What is the purpose? Electric heater, the purpose is, say for example, wet air is there, we have to make dry, so we can apply the electric heater, the hair become dry. Then iron box. Okay, you can iron your shirt, pants, something. Okay, so we require heat only from that device. Okay, so that kind of devices, its resistance is more, so it gives the more heat energy. Okay, so now what is the relationship between that heat and the other things? So that is dealt with the one important effect, that is Joules law of heating effect. Joules law of heating. Joules law of heating effect. I say that nothing. So Joules law of heating. So say for example, here that heat energy is dissipated. So energy is nothing but, that is work done. So we know that basic formula for work done and power relation, because here time factor also will come. So time factor also will come. So that is, power is equal to work done divided by time. Okay. Here work done means, what is the work done? How what work done? Work done means one particle moving from one place to another place, like that here charge is moving from one terminal to the another terminal. Okay, so you know very well that charge on the work done relation, that is Q is equal to work done divided by potential. So therefore work done is equal to Q into V. So I can write power is equal to this work done, I can write Q into V, then divide by T, Q by T. What is Q by T? Q is equal to IT. So I is equal to Q by T. I is equal to Q by T. So we can write power is equal to I into V. So I can write VI. Q by T is nothing but I. So power is equal to VI. So product value of current and voltage. This voltage and the current value, that is known as power in the circuit. Okay? Right. Then one more way. Listen. You know that power is nothing but work done divided by time. So work done is nothing but energy, form of energy. So here heat energy. So heat divided by time. So this power I can write as heat divided by time is equal to V into I. Therefore heat energy is equal to this multiplying here VIT. Okay, so the heat formula, voltage into current into time. Okay, now in this equation, that is H is equal to VIT, in this equation we can apply, we know from Ohm's law. From Ohm's law, you know that V is equal to IR. So now this value is substituting here. So I can write H is equal to V equal to IR. So I into R, then IT. So H is equal to I squared, see that I squared RT. So this is known as Joules Law of Heating. So the Joules Law of Heating, that generally that heat is directly proportional to square of the current. The heat is directly proportional to the resistance of the given wire. The heat is directly proportional to the time taken. Okay. So for example, I will pass the more current. So the heat energy will be increasing. That is the meaning. Like that, the resistance of the wire will be more. So the heat energy also will be more. Say for example, now I am going to switch on the electric heater, only 5 minutes. Then one more electric heater, it will be run more than 1 hour, which will produce more heat. The more time electric heater will produce more heat. So directly proportional to time. Okay, so the resistance should be more, then only we can get more heat. Okay. Say for example, electric heater having more heat, having more resistance. அதனாலதான் என்ன ஆகுது? One important point, its resistance also more, melting point also more. அதனால எவ்வளவு ஹீட் கொடுத்தாலும் அது பேலன்ஸ் பண்ணி நிக்குது. Electric heater and iron box, its resistance value also high and the melting point also high. Suppose melting point கம்மியா இருந்தா என்ன ஆகும்? When the resistance value increasing and heat value increasing, but the melting point less means it will be melted. Okay, அப்ப என்ன ஆகும்? Let's take vessel filled with water to put one electric heater, then switch on. What happened? If it is more melting point means it will be stable. If it is less melting point, what happened? Due to the more heat, it will be also melted. Then you have to search the water heater. Okay, so please remember, So the dielectric heater having more resistance and more melting point. Okay. Then one more thing, in the fuse wire. Actually, the fuse wire is the resistance is more, but melting point is less. Okay. So for that only, if any high voltage will come means it will be fused. Okay. So we will be discuss about the electric fuse in the next chapter. Okay. I mean the next topic. Okay. So we discuss only the electric heater. Electric heater, the resistance is more, so the melting point also already is more. So we are going to use. So please remember students, this is Joules law of heating. The producing heat is directly proportional to square of the current and directly proportional to resistance of the given material and directly proportional to, that is the time factor. Okay.